Hello, this lesson is on the graphs of logarithmic functions, and this is out of our textbook, the Haese Harris book, looking at two example problems out of our textbook out of section 4G. The first one, exercise 1, asks you to do several things taking a look at a graph. And so the function in particular that I will use is log base 5 of x minus 2 minus 2. And first I wanted to talk a little bit about how do you get GeoGebra to graph something of log base 5. Well, if you start typing in some sort of a log function, it defaults to either log base 10 or log base 2. You could also do natural log and that will come up, so log base e. So if you're going to do something other than those bases, what you have to do is you have to type in the change of base formula. And the way that works is if you have log base 5 of x, you can take the log of x in the numerator and the log of 5 in the denominator, and that'll graph log base 5 of x. And it doesn't matter if it's log or natural log, and so that'll do it. So this is the graph of just regular log base 5 of x, and it follows a typical log pattern here. So there's a few things that we need to observe. First of all, it crosses the x-axis at 1. And then the other thing is that it gets infinitely close to the y-axis, but never actually gets there. So it has a asymptote. The y-axis is an asymptote of this function. There is no horizontal asymptote. It doesn't rise very quickly, this function, but it will go vertically forever. So we would say that the domain would be any x greater than 0, and the range would be all real numbers. So that's the first part that we were supposed to solve. Find any asymptotes and x-axis intercepts. We just talked about that. Here's the sketch of the graph. And then we are supposed to find how to solve this function equaling 1. For what value of x does our function equal -1? I won't do that for this one. What I'll do is I'll go ahead and do a different example, a little bit more involved of an example problem. And so I'm going to do part C, 1C, and it says log base 5 of x minus 2. So what I'm going to have to do is I'm going to have to do the log of x minus 2, and I'll have to put these in parentheses, and then I'm going to divide that by log of 5, and then in the end, oops, got to add some parentheses here, and then I have to do minus 2. Okay, so there's our new function, and it's the exact same curve, it's just slid over, and we should have been able to predict that. This -2 inside the parentheses with the x will move it to the right 2. So if we follow this point here, and we go 1, 2, it moves right 2, and then the -2 out on the right moves it down to 1, 2. So here's that point translated right 2 down 2. So here's our new graph. The shape of this graph is totally the same. It's just moved to a new location. So that is the sketch of our graph. Let's take a look at the domain and the range. Well, because it's the same shape, all the qualities of this graph just sort of translate as well. So the horizontal, the asymptote, the vertical asymptote, just moves over 2. So now it's x equals 2 is the vertical asymptote that that this graph gets close to. Now where does it cross the x-axis? I can hold the shift key and drag over and see where that might be. Whoa, it's a lot further over than I expected. So it looks like 27. Okay, so the x-axis, the x-intercept is now at 27, and here's our graph again, and now it wants us to solve for wants to know for what value of x will our function equal -1. Okay, so what I've done is I have written out this equation, and I've changed here's our function, and the question asks us, well, where is this function equal to -1? So I set it equal to -1 here. And what I've done to get to this next step is I've added 2 to both sides, and then I switched the left and right sides. So, so I get this expression here. Now what I'll have to do is I'll have to undo this log. I'll have to do and what I'll have to do is I'll have to remember how to read this. A log is an exponent. So the exponent of 5 that gives us x minus 2 is 1. So the exponent of 5, so 1 is the exponent of 5, that gives us x minus 2. So we can rewrite this equation to look like this instead. These are exactly the same. Okay, so 2 different representations of the same thing. Now it becomes easy. 5 to the 1 powers, and we get x is equal to 7. Okay, so we've done part 4 there, we've solved, and then part 5 says find the inverse function and explain how to verify your answer. So the process of finding inverse function is we begin with the original function, and I've changed f of x to y just to make the notation more simple. So f of x changes to y, and then to find the inverse function, we switch the variables, we change the places of x and y, and now what we're going to do is we're going to solve for y. We're going to get isolate y, and that will become our inverse function. So what I've done here to get this next step is the same thing. I added 2 to both sides, and then I switched the left and the right side. So I moved this over to the left and then the answer over to the right. Okay, and again, log is a exponent. So the exponent of 5 that gives us y minus 2 is this. So I can write 5 to x plus 2 is equal to y minus 2. Now I only have one more step to solve for y, and that is to add 2 to both sides. So this is our inverse function right here. So this is the inverse function that they were asking us to find. How do you verify your answer? The way you would do it is you would substitute this function in for x up here and solve, and it should just give you x. And then you do it the other way around. So what you'll have to do is you'll take this function up here, and you'll have to substitute it in here for x and simplify, and it will give you x. So if you get x both times that you do that, then you have verified that it is in fact the inverse function. So that's how you would do it. It doesn't actually ask you to do it. So I'll just leave it at that. So that's number 1 on page 136. What I'm going to do now is I'm going to go on to number 2. You were assigned letter A, so what I'm going to do is I'm going to do letter B to show you how to do that. All right, so in letter B, the function that they give you is this, and this is what it looks like graphed. Okay, so an exponential function. We should notice that this plus 1 up in the up with the x moves the graph to the left 1, and then shifts the graph down 3. So what it normally would cross at 1 here on the y-axis, just the plain old e to the x. So we're going to go left 1, down 1, 2, 3. So this is where that point has shifted to. Okay, so the first thing they want us to do is find the inverse function. So going back to this document. Here is the function that they give us. Again, I change f of x to y, just make it easier for notation. I switch the two variables, and now the goal is to solve for y, to start isolating it. So I'm going to add 3 to both sides. I switch the sides, and then what I can do to get rid of this e is I can take the natural log of both sides. So natural log and e, they're inverses of each other. They cancel each other out. So now all I get is y plus 1 on the left side. And then I get the natural log of the right side over here. Now all I have to do is add 1 to both sides, and this is my inverse function. All right, so we have found the inverse function. Now it wants to sketch the graph of f and the inverse function on the same set of axes. So I got to memorize this. So we're going to type in y is equal to the natural log of, what was that, x plus 3, and then it was minus 1. Okay, and so we should observe a few things. This, when we see the graph of inverse functions, it's always one of them flipped over the y equals x line. All right, if I type in y equals x, you should see that it flips right over that line. So it's a mirror image. If you put a mirror here for the y equals x line, one function will be the mirror of the other. Okay, so it looks like it's checked out. Looks like we were successful, and now it wants us to state the domain of range of both of them. All right, going back to our original function here, the exponential function, the domain, it goes infinitely to the left and to the right. It doesn't look like it goes to the right very quickly. It doesn't, but it does go to the right infinitely far. So the domain is all real numbers. The range, actually, in the normal exponential function, it gets infinitely close to the x-axis, but it actually never gets there. So now that we've translated it down 3, we can say the range is all y's greater than -3. Okay, so that's for the original function. Here's the inverse function, and we should be able to see that it gets infinitely close to x equals -3, this horizontal vertical asymptote. All right, so again, since we're flipping, or over here when we had the horizontal asymptote in -3, since we flip it over the y equals x line, now it flips over to this position. It becomes vertical at x equals -3. So that's what happens to the asymptote. All right, so the domain is going to be the range of this function. So the range of the original function becomes the domain of the inverse function. So x is greater than -3. All right, and then also the range of the original function, the domain of the original function becomes the range of the inverse function. So they just switch. Okay. Finally, we are asked to find any asymptotes. We just talked about them, and that is number 1 and number 2 out of the book. Hopefully this is more clear for you, that some of these concepts are starting to sink in. If not, come and find me. All right. Have a great snow day.